All right, we will go ahead and get started. Thank you all for joining us today for the Parkview at Terwilliger Plaza Passive House Design webinar. My name is Teresa Omart, and I am the Sales and Marketing Director at Terwilliger Plaza. A few housekeeping items before we get started. I did receive some questions from some of you. We will most likely get all of those answered in the presentation. If not, and you have other questions, please feel free to enter those in the chat. And we will do our best to answer those today. Rest assured, if we can't get to those today or we don't, then we will definitely follow up with you to make sure all of your questions are answered. So we'll go ahead and get started. I can't tell you how excited I am to be part of the launching of Plaza. For those on the call who do not already know, Parkview at Terwilliger
Okay, no, share screen now. I don't want to do that.
is the newest addition to our community.
See, start video is deleted, so you want to delete. See down at the bottom. Start. Okay.
There we go. Sorry about that. So Parkview will have 127 apartment homes ranging from 1 bedroom with a den to 2 bedrooms with a den. We are currently reserving homes and will begin construction this fall. As you'll see today, Parkview will be extremely energy efficient and will reduce its ecological footprint by using passive house design concepts. As we've been launching Parkview, we have welcomed our first 10+ charter members, and passive house design, and again, the concepts for passive house design continue to come up and be what we're calling hot topics for most charter members, reservation depositors, and prospects. They're eager to learn more about it. So here we are today to share these concepts with you. We're very fortunate today to have Peter Housknecht of LRS Architects with us. A little bit about Peter. He is a creative and experienced architect who is very passionate about sustainable design, particularly passive house, net zero, and the living building challenge. He has a diversity of experience and has worked all over the world, but throughout it all, he's maintained a laid-back demeanor and strong sense of humor. Please welcome Peter.
Hi, Peter.
Teresa, not everybody is muted.
Thank you.
Okay, is everybody able to hear me? Okay, good. So Passive House is a sustainable design program that was originally developed in Germany, and it's really geared to minimizing a building's energy needs, and it does this by achieving very dramatic energy reductions. So, and it's all done virtually by all passive non-mechanical means, with one simple exception being an electric fan. It's a very big and expensive fan, but that is the only mechanical device that's directly related to achieving these energy savings. And we'll talk a little bit about that more later. So basically, we're designing a building where these energy savings are inherent in the building envelope. And there is also some other chosen strategies to reduce electricity use in the building. But boiling it down to its most simple essence, it's like designing a building enclosure that's like a thermos. So it's a very uniform envelope with minimal interruptions, and well sealed, that keeps all the heat and or cool in, depending on whether you're in air conditioning mode or heating mode. So Passive House was selected for Parkview because the Terwilliger residents were interested in making some type of sustainable difference in the world without necessarily certification or badges, greenwashing. They wanted to do something that was really going to make a difference. So Passive House is all about producing building performance results. In a large commercial building like this, we can expect to see 50 to 60% energy use reductions over a typical code compliant building. Single family homes can actually get into the 80 to 90% range with this, but large buildings with a lot of occupants present a completely different dynamic when designing buildings. To give you an example, Parkview residents will provide the majority of heat required for the building, so much so that you probably won't even need to turn on your heat till it gets close to freezing for most people, and the cooling loads in this building are 3 times greater than the heating loads, just simply because of the number of anticipated occupants. So Passive House is all about conservation, which is really the foundation of sustainable design. And what better way to mitigate energy use than to eliminate the need to use it in the first place? Plus, it's a win-win for everything. Both for the Earth and Parkview residents will be a lot more comfortable, and we'll talk a little bit more about that as we go along here as well. So the other aspect of this is Passive House is a perfect match for senior living facilities. Due to its high performance, it maintains thermally uniform spaces throughout the building that are also very quiet. And that is 2 of the major things that we hear about a lot when we're designing senior facilities in terms of what residents want. And Terwilliger residents made it very clear to us in our initial conversations that they wanted to be very comfortable and not challenged thermally. And they were also very concerned about noise and acoustical performance with the building. So you can move on to the next slide, Tracy, if you will. Oh, one before that, I think you might have jumped. Oh, I'm sorry. You're good. Yes, this will work. So I wanted to just share with you how some of these elements actually manifest themselves in the building that are representative of this program. So first of all, the building's designed to its specific climate and location, and we use very sophisticated energy models that actually emulate how much energy the building's going to use. It takes weather into account, temperature ranges, and also we analyze global warming as part of this in terms of there is new data out now that we're designing buildings to where the climate is getting warmer. And I think some of you probably experienced some of the high temperatures that we've had over the last several summers in Portland as an example of that. So for Passive House, this winds up for this site being anywhere from 50 to 100% more exterior wall and roof insulation for thermal performance. We also make the building very airtight. And this is throughout the exterior wall and the roof construction, and this is for thermal performance as well. It controls the air quality in the building, which we'll talk more about later, and it also contributes to its quietness. So as part of sealing up the building, we use very high performance European design tilt and turn triple glazed windows, and these are essentially the best windows that you can buy in the world. They have triple seals in them. So it's really seals out the weather and air infiltration, multi-point latching, which keeps the seals engaged. It also helps the windows last a lot longer because things can't warp because they're all locked in around the entire perimeter of the frame. And also the frames themselves are very high performance thermally. So we're also providing a 100% fresh air ventilation system, and this is where the fan comes in. This is part of Passive House, where with the building sealed up, we have a continuous flow of 100% fresh air into all the units and all the amenity spaces throughout the building. So we do this because this recovers the thermal energy of the exhaust air. So exhaust air in your unit, for instance, will be drawn out through a vent located, one in your kitchen and one in your bathroom, that will be running at a low rate, but will be running 24/7. And this air is passed through a series of mazes, if you will, that parallels a similar set of mazes for fresh air coming into the building. And this is done at the rooftop so that this unit captures the thermal energy of the air that's coming out of your unit. So your unit, when that air was present, energy was expended to either cool that air or heat that air to the desired temperature. So what this system does, by a simple fan and a maze of vents, or ducts, I should say. Oh, you jumped ahead for me here. So this is a diagram of this. Basically captures the air from the that's being exhausted from the inside, tempers the fresh air coming in, and delivers it to your unit. So you can go back to the other slide now. And so in addition to capturing this this air, back to the elements, if you will, Teresa. Keep going. There we go. So this also allows us to control the quality of fresh air in the building as well. So you're always getting a fresh supply of fresh air, even if you have your windows closed. And it's going to be coming into your unit within a few degrees of the room temperature, so it's not going to take very much energy at all to bring that up to temperature. So in addition to that, we have fixed exterior sunshades on the windows to keep the sun off the glazing during most of the year to reduce the air conditioning needs. We have a solar system on the rooftop, and this is going to provide a substantial portion of Parkview's electricity. We use LED lighting throughout, which is the most efficient lighting available and is maturing very well in the market. And then we also use very high efficiency appliances. A couple of these we'll touch base on in a little bit. One of them being a heat pump clothes dryer and another one being a high performance range hood. Both of these are ductless systems, and we'll talk a little bit more about that later and why we chose those things. And then we're also providing ceiling fans in the living rooms and bedrooms, so this will help with your comfort in those spaces. So we can jump to the next slide, Teresa, if you will. So these are the tilt and turn windows. And as I mentioned, these have very high performance frames, very well sealed. And the way these work is you see the first picture there to the left is the window in the closed position. The tilt function is when you turn the handle in one direction, the whole window panel, that's the portion of the windows that are operable, swings out, and this provides you with ventilation air with still having the window very secure. And you can't open this window when it's in this position. It's as good as locked. And then you have full operation of the window when you turn the handle in the other direction, and this operates as a casement window. So it is hinged on the side and will open up into the room with screens on the outside. So this makes the windows very easy to clean inside and outside. The hinges are all concealed, so you're not seeing a lot of hardware. The only thing that shows is the handle on the window itself. And these are very hefty windows. I think once you operate these, you would never want to use a different window again. They're European engineered, and it's kind of like as solid as a European car door would be. And these are very long lasting windows as well. So we can jump to the next slide here. So this is just a diagram that we started with shading the windows, and we analyzed each building facade and where the sun was coming from. Windows on the south side, for instance, would have a side panel on both sides and a head panel to keep the sun off the glass. And then east and west exposures would have, some of those would only need one side panel. And then on the north wall, where there isn't any direct sun, we don't need those at all for obvious reasons, because the sun won't be hitting the glass there. So this device alone reduces the air conditioning needs substantially in the building and allowed us to get those loads down. So we can go to the next slide, please, Teresa. And again, this is the heat recovery ventilation system that's on the roof, and which we've already talked about. So we can jump to the next slide. Now this is the high performance ductless range hood, and this is not a typical range hood by any means. You can see on the left there's kind of a diagram of a typical range hood and a rather high-end one at that. And the one on the right is Venahood's version of this. They have a patented system to remove the grease in the first stage from the exhaust air. And then this air runs through a carbon filter in the next stage. And then above that runs through a smoke filter before this air is returned into the room. And the reason we do this is a lot of air is, and a lot of energy is lost when you have ventilation being ducted directly to the outside, which would be the conventional way of running an exhaust hood for a kitchen. And so all that energy that went into heating your room or cooling it during the summer would be dumped to the outdoors and would be thoroughly wasted. So this is where the fresh air ventilation system comes in as well. And in addition to this, we have, as I mentioned before, a vent that's going into the ventilation system in the kitchen itself. So even some of the, if anything were to escape from this hood, it could be captured by the ceiling vent in the system and carried to the outdoors, but that energy would be recovered by the rooftop ventilation system. So the next slide, please. And then one of the other ventless appliances is the dryer, which for the same reasons would dump a lot of energy out of the room and into the atmosphere. So these are front-loading washer and dryer. The washer is a conventional front loader, but very high efficiency, amongst the best in the world. The dryer is what uses a heat pump technology to dry your clothes. And essentially what this does, it's a lower temperature dryer, and it uses heat that's generated by the heat pump, but is much lower heat than what you would see in a conventional dryer, so your clothes aren't getting cooked. And what it does is it passes air over your clothes, and the warmer air picks up the moisture from your clothes, and then it circulates through and condenses on coils that drip into a pan, and then they're carried out into the same discharge as your washer discharge pipe. So there's no ducts that are needed, and since the system operates on both heat pump and a very low temperature, this is not going to introduce a lot of heat into your room, and it's not going to introduce a lot of humidity into your room as well. And just to give an example, these dryers are save about 60% of the energy that a conventional dryer would require to do the same work. And these just take slightly longer to dry a load of clothes than a conventional dryer would. And they're very quiet. So at Terwilliger, we actually got samples of these for Terwilliger to experiment with, and they wound up buying the units and putting them into all the renovations as a result of that test. So the next slide, please. So these are some of the other sustainable features that we've introduced to the building. These don't have directly to do with Passive House, but we've carried this through where we could and had opportunities to do so. So the main building, as well as the sky bridge connecting to the existing campus, will have a green roof. And you can see an example of this here. On the main building, there'll be solar panels on top of that roof. There's a nice symbiotic relationship between the two, where the solar panels help shade the sedum, which help keep them from drying out, and the sedum helps keep the solar panels cooler, which increases their efficiency. And this also provides habitat. It reduces the heat island effect, improves the aesthetics of the building roof, and it also cleans rainwater. So we were able to collect this water in which stays in the soil for a while, where it gets filtered, but also defers it going into the storm system. So when there's a big rain event, the storm systems of the city aren't overwhelmed, and this slowly introduces water back into that system, just as nature would in the forest. So the green walls, which are more prevalent in the west side of the building facing the existing campus, also provide habitat. It was a way to enhance the view for some of the existing residents, and it does a little bit to reduce solar heat gain, but not by a great deal. And you can see an example of that of a beginning system that is starting to grow on the lower right-hand picture there. And we are actually using those same products that are shown in that picture on the side of the building with the planter boxes and the three-dimensional screens for plants to grow up. So the stormwater planters we have in a variety of places. They exist on the courtyards mainly, but I think we have some on the roof as well. And these also filter rainwater and defer it from going into the storm system, and also reduce the heat island effect. So you can see an example of those. This happens to be in ground, this picture on the lower left, but it will have plants in there that are going to be water tolerant, because there'll be some times when it's flooded after a large rain event or a series of days when it's raining. But eventually this will dry out, and it will look different throughout the year depending on the seasons. So the next slide, please. So what does Passive House mean for residents? And the biggest difference you're going to notice is that Passive House buildings are very thermally comfortable and very stable throughout the space. And that means you're going to be just as comfortable sitting by your window as you are in the interior of the space, because everything's going to feel very uniform. And just like a thermos, this building isn't going to take hours to cool down or heat up. Depending on the time of year, it will take days, just as you would when you came back from a trip and you left the ice in your cooler and you got up the next morning and you open the lid and there's still ice in there. Well, the interior spaces of this building are going to take a long time once they're cooled down to the temperature you want or heated up to the temperature you want to deviate from that temperature, as they're going to hold on to that temperature for a long time. So in addition to that, you really aren't going to be making any lifestyle changes to be saving a lot of energy, because all these energy savings are inherent in the building itself. And so you'll be decreasing your ecological footprint, just going about your daily life. You will have opportunities if you want to increase your energy savings for the planet and decrease your ecological footprint just by choices that you make, by turning down your thermostats, making choices about your water use, your transportation choices, so on and so forth, just as you would in any other facility. But you're already going to be doing a lot. Passive House probably saves in the range of, for a large commercial building like this, 50 to 60% of energy use is over a conventional building. And otherwise, there's not going to be any special procedures, routines to adhere to, or fancy equipment to operate. You'll not even notice most of this. So at the same time, Parkview has a very highly efficient and complete heating and air conditioning system with unit controls in all the individual units. So you'll get to set your thermostat to your own personal preference. You'll not be asked to tolerate a few extra hot days or cold days during the year to save energy. If you elect to do so, that'll be your personal private decision. You'll have complete control over the temperature of your unit. And other than that, you can, I think, just be proud of the choice that you made to live in a special building that is on the cutting edge of building science and performance. And if you choose to do so, it is my sincere hope and purpose in this project that this building will serve you really well and make your life easier, more pleasant, and more comfortable. So with that being said, that's, kind of a quick overview of what Passive House is about, but I'm happy to answer any specific questions that you may have or concerns.
Thank you, Peter. Right this moment, I don't see any questions in the chat, but if you have questions, if you can go ahead and enter them in there. I believe the passive house specific questions that we had prior to the webinar were answered in the conversations about the dryers and the stoves and the ventilation. And so if you have any other questions, please enter them in the chat.
Okay. So I see one question here. Can you talk about the walls and the roof? And I'll be happy to. So the walls are framed with 6-inch studs that are filled with insulation. Then we have an additional 2.5 inches of insulation that's on the outside of that wall. It's in what we call rain screen cavities. So the facade material itself is separated by an airspace from the interior wall. And the interior wall is waterproofed on the outside. It's done with a special waterproofing that's kind of like Gore-Tex fabric that allows moisture from the building to escape into this cavity. And then any moisture that would work its way through the facade would also escape in that cavity. And so it keeps the building very healthy. The continuous insulation is actually more valuable than just the 2.5 inches because it's continuous. And then on the roof, we have 12 inches deep of rigid insulation, which is probably twice as much more, depending on what code you're comparing it to, than we would do for a conventional code building. So I hope that answers that question. If not, feel free to ask me another one. So that's the walls and the roof basically form the thermal envelope. So any part of the building that's separating interior space from the outdoor elements is basically what we call the thermal envelope of the building. So the next question is the expected completion date. It would be about 28 months from this coming fall when they start construction. And let's see, the next question, do opening windows and doors to the decks, looks like maybe you're trying to ask if it compromises anything. Well, if that's the question, the short answer is no. I mean, you're likely not going to be opening your windows and doors on a severe cold or a severe hot day. You're going to be more comfortable if you don't. But you can open your windows and doors anytime. You know, it's only going to affect the temperature of your unit, which is going to recover very quickly if it happens to be really warm or really cold outside, and you still wanted to open your doors and windows anyway, but you wouldn't have any big impact on the performance of the building. Let's see, if the units adjacent are at 75 degrees, is it harder to keep 69 in your own unit? No, I don't think you're going to be very affected by that at all. I mean, as a whole, the building's going to help keep everybody warm and comfy, without a doubt. But there is sound insulation in the demising partitions between units, and this few degrees in temperature is not going to really have an impact. And the next question, will the windows be safety glass? Thinking earthquake damage. They are safety glass where required by code, which is generally the doors and the windows immediately around the doors, and any windows that are below, I think it's like 18 inches above the finished floor, are all safety glass. But the glass in here is going to be very stout. It's going to take a substantial earthquake to break any windows in the facility. And if we have the really big one, I mean, nobody knows really how much damage is going to be done from that. You know, that's a difficult one to say, but you know, the railings are going to be safety glass as well. And I can get more information as to what's being provided in all the windows, but they're going to be safe. There's no doubt about that. The next question, what happens in a power outage in the neighborhood or citywide? There is a generator for the whole building inside. Now, it won't run everything, but it will run all the essential elements in this building. And as I alluded to before, one of the benefits of Passive House is even if the power goes out, your unit is going to hang on to your temperature for quite a long time. I mean, you know, days, not hours, days. So you'll be better equipped to handle this than most buildings will. And the facade materials, the main facade material we're using is a product called Equitone, which is a very, very high density fiber cement. This is not like Hardy Panel, which some of you may be familiar with. It's a kind of generally similar material, but this is much higher performance. It's much denser. There isn't delamination issues with that. And it is correspondingly equally more expensive than Hardy Panel is. So this is a commercial material that's rated for high-rise construction and the wind loads that would be associated with that. So let me know if I have not adequately answered all the questions that I'm seeing here. I'm happy to delve into more detail.
Thank you, Peter. This is Teresa. I don't see any others right now, but good thing is I know where to find you if someone reaches out to me and wants some more information. So thank you very, very much for putting this presentation together. We're all super, super excited about Parkview, and I think we're going to start seeing some activity and some demolition happening in the next week or two. So that's pretty exciting. So it looks like June, what earthquake reinforcement is built into the building?
Yeah, so this building was brought up to, well, when we designed it, we were under an earlier code, which has now taken effect, but we were designing it to the current building code. So this is basically a level 2, which is required by code. And this is per the latest code that was just, building codes that were just adopted recently.
Great. Thank you so much, Peter. Certainly, if you have any other questions, please let me know, and I will make sure that we have all the answers that we want.